All right, you should have kind of determined from the investigation that you just did in GeoGebra that when you have a tangent line and a radius, they form a 90-degree angle. So this angle right here is 90 degrees, or a right angle. So a tangent line always forms a right angle with the radius drawn to the point of tangency. In other words, if it's not 90 degrees, then it's not actually a tangent line. The radius and the tangent line always have to form a 90-degree angle. Okay, so let's look at a couple examples. So in the first example, we want to figure out if the line drawn is tangent to the circle. So it looks like it's a tangent line. It looks like it touches at just that one point right there. However, to know for sure that it's a tangent line, we have to verify whether or not that angle is a right angle. Well, if it were a right angle, then this would be a right triangle. Well, we know the three sides, so to check to see if it's a right triangle, let's plug it in the Pythagorean theorem. 18 would have to be the C, because that is the hypotenuse. So we're going to write 6 squared plus 15 squared equals 18 squared. We're going to figure out what this is. 6 squared is 36, plus 15 squared is 225, equals 18 squared is 324. If we add the left side, we get 261 equals 324. Well, 261 does not equal 324, so this is not a right triangle, which means that this is not a right angle, which means that it's not a tangent. All right, slightly different example. In this case, we're told that the line is tangent. So that means we know that that's a right angle right there. And we want to figure out the length of the radius. Well, the only segment on this picture that is a radius is from the center to the edge. That's the radius in this picture, which is our x. So if we know that's a right angle, then once again we've got a right triangle, and we can use the Pythagorean theorem to solve for x. This 18 is still our c, so we're going to write x squared plus 15 squared equals 18 squared. X squared plus 225 equals 324. Subtract 225 from both sides. We end up with x squared equals 99. And then the last thing we're going to do is take the square root, and we should get that x equals 9.9. So I just took the square root of both sides, and we got x equals 9.9. All right. In addition to the fact that a tangent line forms a right angle with the radius, there's one other theorem about tangent lines we need to discuss. And that's if you have two different tangent lines. So both of these lines are going to be tangent in this problem. They each intersect at one point. And then they also intersect each other at some point outside of the circle. Well, what this theorem says is that the segments formed by those two tangent lines that intersect outside of the circle are congruent. In other words, this segment right here and that segment right there are the exact same length. It almost looks like a sideways cone or birthday hat or something. Well, if they're congruent and we want to solve for x, anytime segments are congruent, we can set them equal to each other. So all we have to do is write 2x plus 12 equals 34 and solve from there. So subtract 12 from both sides. We get 2x equals 22. Divide by 2, and x equals 11. That's it.